A survey is being conducted of voters' opinions on several different issues. What is the overall margin of error of the survey at 95% confidence if it is based on a simple random sample of 1,111 voters? Here's just some notation. P is the unknown population proportion of voters that support or do not support some issue. We don't know this because we would have to survey the entire population, and of course that's not practical. The population could consist of millions of voters. P hat denotes the estimate of P. The estimate of P is based on a sample. Okay, so we've a sample of 1,111 voters. Sample size is denoted by little n. So we survey this sample, asking the voters in the sample what their opinion is on some issue, and we get the proportion of the sample that agree or disagree on some issue, and that's our p hat, and that's the best we can go on as an estimate for p, because we can't survey the entire population. From statistical theory, we know that p, the unknown population proportion, lies within 1 over root n of p hat with probability 0.95. 1 over root n is called the margin of error of the survey. Strictly speaking, 1 over root n is the 95% margin of error. If we want a 90% margin of error, we have a different value here actually, but we will just be dealing with the 95% margin of error. So we just calculate 1 over root n, which is 0.03. So basically what 0.03 means is that the probability that p hat minus 0.03 is less than p hat plus 0.03 is 0.95. So p is unknown. We will normally know p hat. We get that from our survey. A political party had claimed that it has the support of 23% of the electorate. Of the voters in the sample above, this is the sample of 1,111 voters, 234 stated that they support the party. Is this sufficient evidence to reject the party's claim at the 5% level of significance? So the null hypothesis here is that the population proportion of the electorate that support a political party is 23%, 0.23. The alternative hypothesis, HA, is that P is not equal to 0.23. Now our sample has size 1,111. An estimate of P hat is got by taking the number of people in that sample that support the party, which is 234, and dividing it by the sample size n. To 3 decimal places we get 2.211. So this is the proportion of the sample of people that support a particular political party. From statistical theory, we know that P lies within 0.03 of P hat with probability 0.95. Let's just write down this statement for P hat equals 0.211. So we're going to have 0.211 minus 0.03. That gives us 0.181 less than P hat plus 0.03, so 0.211 plus 0.03. That gives us 0.241, so this probability we know is 0.95. We can see that 23% or 0.23 is between 0.181 and 0.241. In other words, 0.23 is in the confidence interval 0.81, 0.241. That means that we do not reject the null hypothesis that P is 0.23. Strictly speaking, our confidence interval is the 95% confidence interval for the population proportion P. So we can say that we have insufficient evidence to reject the party's claim. A 5% significance level is based on the party's claim being true. We have a 95% chance that P lies between 0.181 and 0.241. That means that we have a 5% chance that P is not inside this interval. Everything we have said is based on the null hypothesis that the party's claim is true. In other words, P is indeed 0.23.